Jim, we copied both solar wind and penetrometer drum in the ETB.
Not quite yet. I haven't put the solar wind in yet, but I will shortly. I want to watch this. Joe, you have a good picture there. I've got...
Beautiful picture, Dave.
Well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his findings.
Superb.
Good evening and welcome to the August 2021 meeting of the Mornington Peninsula Astronomical Society, performed during lockdown once again, where we can't meet at the Briars. This particular month we celebrate the 50th anniversary of Apollo 15 going to the moon. Now, Apollo 15 was the first mission to actually take a lunar rover onto the surface, and indeed the two astronauts who went down to the lunar surface travelled an amazingly far distance, given that it was the first tryout of the technology on the moon. They spent 6 days in orbit around the moon, and aside from the lunar rover, they were also the first and only spacecraft to actually launch a satellite itself, and they launched that in lunar orbit. And those satellites, the Particle Field Satellite 1 and 2, those two satellites were due to go in orbit around the moon for about a year, and during that time not only would they show gravity anomalies due to changing in their orbit, but also they were there to measure the particle field around the moon itself and how it interacted with the Earth and the Sun. They also conducted the first EVA or spacewalk, actually in deep space, so in other words not in Earth orbit but well out of Earth orbit, and as far as I know that might be the only one even performed to date. Now, on the first slide you would have seen here the picture from Apollo 15, or the image of Apollo 15, where they were demonstrating the Galileo experiment, famously from the Leaning Tower of Pisa. And in this particular case the astronaut dropped a hammer and a feather in the conditions of no atmosphere to slow either of them down on the moon, and you would have seen that they both hit the ground at exactly the same time, which is exactly what you expect from the physics of it. Now, the next slide celebrates the entire mission of Apollo 15 in a couple of minutes, and I've prepared this one based on an original from the Vintage Space Channel from Amy Shira Teitel, who visited the Briars getting on for about 5 or 6 years ago now, and played it with backing music of Cloud Shadows, which she also used in her original version. tonight. Welcome to any new members of the Society who've joined during the month. Hopefully we'll get a chance to meet you all in person soon, but I suspect it may be several more weeks yet until that becomes possible. But nevertheless, welcome to the Society, and if you have any questions at all, feel free to send them to either the Society email address, eScorpius, which would have been sent to you in your welcoming email by the new members officer, Nerida. Or alternatively, if you don't wish it to be sent to over 300 people on that list, then send it to the Society's public email address of welcome@mpas.asn.au, and a much smaller selection of members will have a look at that and potentially be able to answer it for you, including Nerida. Now, we'll first of all look at what events have occurred in the past month and the coming month, and indeed there's been quite a lot that didn't happen because of the lockdown. Then we'll go into the National Science Week talk, which was due to be given in 2 days' time from now rather than today, but due to circumstances of the lockdown, we've had to bring it forward into this meeting during National Science Week for 2021. And Trevor Hand, a long-term member of the Society, will be given a talk on shooting stars as part of the natural environment, and that's followed by questions that were conducted over Zoom at the time today. Following the main talk and the questions, Mark Stevens will be giving Sky for the Month for August, and then following that will be 4 science-related videos, all on the subject of meteors or meteorites. So you can see that's pretty much the theme for this evening's meeting. And lastly, we'll close with not only a bit of a musical rendition, but showing the relative gravity on each of the planets of the solar system, and also an asteroid and indeed the Sun, showing a ball actually falling from a height of 1 kilometre above the surface of the planet, and showing how quickly it falls down and what speed it reaches at the end of 1 kilometre. Now, in the case of the gas giant planets, they don't actually have a solid surface, so the surface is taken by the person that put it together to be 1 bar, which is 1 atmosphere of pressure, which is ground level pressure here on Earth on average. So, recent events. This time last month we had the annual general meeting of the Society, which had to be conducted by Zoom due to the lockdown, and at that meeting the changes to the Constitution were unanimously passed. And following that, a week later, we had the committee meeting, which was also conducted by Zoom. And just a reminder that committee meetings are indeed open to any financial member of the Society to dial in and listen to. And unless I actually forget, we'll normally send an invitation round just to prompt you. It's always the same link each time, so if you've got one from a previous month, it'll be the same link the following month's one as well. And last time the main discussion points were on the impact of COVID on our events, which of course would be very significant, especially during National Science Week, which has to be the busiest time of year for us, even busier than usually January. And of course the submission to the Department of Justice as well, which relates to not only the annual general meeting in general, but also the changes to the Constitution wording. On the 30th of June, 30th of July, we were due to have the next SCAG night, the Scout, Cubs and Guides night, and Manfred was due to give the talk, but alas, that had to be called off due to the lockdown. 5th of August, we were due to visit Merricks again for another senior school, Naranga, coming along, and alas, I had to not talk at that one, and it was cancelled due to COVID. Then on the 6th and the 7th of August, we had effectively back-to-back public viewing nights planned, with Trevor and Guido on the Saturday giving the talk, and both of those had to be COVID cancelled as well, alas. 10th of August, we had another scout group lined up in Frankston, but alas, that one had to be called off as well. And another scout group the day after, on the 11th of August, was going to be at the Briars, where Catherine was going to give the talk, but alas, that also had to be cancelled. So lots of impact on the society this month. So what's coming up in the following month? Coming up, we have a number of things that are already cancelled due to the lockdown. Have the second Mornington Sea Scouts, where Manfred was going to give the talk, and public viewing night by Trevor, which is the talk that is being given tonight that ordinarily would be given then. Committee meeting on Zoom is due to be on the 25th of August. And 31st of August, we've already had another night at Merrick's Camp cancelled due to COVID. 3rd of September, another public night at the Briars where Catherine was going to talk has been cancelled as well, because we're not anticipating being out of lockdown by the 3rd of September. All excellent if indeed we are. We can always change our mind and put it back on again, but in all likelihood that's not going to be the case given the number of cases circling at the moment of the Delta variant. 12th of September was going to be the annual astrophotography workshop conducted at the Briars for the public and members to come and learn all aspects of astrophotography. But alas, that has also been cancelled due to COVID, because to actually run that successfully requires a certain number of people to turn up, and with the risk of cancellation, it's likely that that event would not be particularly successful, at least financially wise, and also subject to calling off at the very last moment as well, alas. 14th of September, we've still got a talk lined up for Mount Erin Secondary, but I would say it's very probable that they will call it off unless restrictions ease significantly to allow the number of students to be in the same space at the same time. So although that one's currently open as of the time of this video, it may indeed be COVID cancelled by the time it gets there. And a message to that effect will go on to the eScorpius email group if that is the case. And the next meeting, hopefully at the Briars, will be held on the 15th of September, Wednesday the 15th. So tonight's talk, we have Trevor speaking about shooting stars in the natural environment, and this one is a talk that was supported by not only National Science Week and Inspiring Australia Victoria, but also ourselves, the Mornington Peninsula Astronomical Society as well. Now, Trevor's well known for travelling around the world on cruise ships, at least in the pre-Ruby Princess days, when you could do so very safely, or relatively safely. And so he's obviously taking a necessarily taking a pause from giving those talks, but I'm sure he'll be right back to it as soon as the borders open and cruise ships are running safely again. Now, I suspect that might not be tomorrow. It'll be a little way off as yet. His background is from the old Telecom, when it used to be called Telecom, and he was at the research labs in Clayton, which was a building that used to be right next door to where the Australian synchrotron is at the moment, across the road from Monash University. So with that, we'll just go straight into the talk from Trevor. Right, so the talk tonight is going to be given by one of our long-standing members. He's been a member of the Society now for over 13 years, Trevor Hand, and he's on the call. At the end of the talk, Trevor will show a number of real meteorites as well. If this was being done face-to-face, you would have been able to actually hold them, smell them, sniff them, taste them, do whatever you like, but you're not going to be able to do that over Zoom, unfortunately. But hopefully you'll be able to see what what real ones look like, and get some idea of what they're like. And also, right at the end, if you haven't already entered the competition to win a meteorite, it is Australia-wide and open to school kids of all ages as well. And we'll give you some of details of those.
Good evening. My talk tonight is on shooting stars as part of the natural environment. I'll be talking about what shooting stars are. Are they random? Do they just burn up and disappear in the atmosphere? Could I actually hear them? And what would happen if one was to land in my backyard? Would I be able to touch it? So if you go outside late at night and look up into the skies, you may see tiny little flashes of light. Now these could be random pieces of dust or small stones that perhaps have been floating in the atmosphere, in the solar system for many billions of years, and they've just entered the atmosphere as you've gone outside and looked up at the sky. Some are actually remnants of comets. If we look at the surface of a comet, it's covered in ices of carbon dioxide, methane, ammonia, water, and a number of other chemicals that are very volatile when they get heated up. As a comet approaches the sun, the radiation from the sun warms up these chemicals, creating a visible tail. These particles can then be thrown out into space and they tail behind the comet in the same orbit, and they may remain in that orbit around the solar system for perhaps thousands of years. To give you an idea of how big some are, this is a picture of the comet Churyumov-Gerasimenko, which is about 5 kilometres wide. It's actually being superimposed upon the city of Melbourne. You may see the exhibition centre down in the bottom right-hand corner, just to give you an idea of just how big some of these comets are. Now, as the comets orbit the solar system, some of them actually pass through the orbit of the Earth, and at some time the Earth will pass through the remnants of this tail, creating a potential meteor storm. So, for example, Halley's Comet, which most people have heard of, we travel through the tail of this comet in October, and it creates the meteor storm called the Orionids. And another comet, Tempel-Tuttle, we pass through its tail in November, creating the Leonids. Now, they're named for these particular constellations that we would see the meteor storm appear from. If we were to look in the direction of the constellation of Orion at the right time of the year, we would see these tiny shooting stars appearing from a particular location in the constellation of Orion. When you see these shooting stars, you're not actually seeing the object itself. At a distance of 100 kilometres or so, you certainly cannot see a speck of dust or a small stone. But when they enter the atmosphere at perhaps 10 or 20 kilometres per second, they move far too fast for the atmosphere to get out of the way. And so the air in front of this object builds up and is compressed until eventually it begins to glow white hot. It's that compressed white hot atmosphere that is what you're actually seeing, not the speck of dust or the stone. Because most of these are quite small, they actually burn up high in the atmosphere and they never make it to the ground. It's estimated there's about 1,000 tonnes comes through the atmosphere of the Earth every day, even through the daytime. They're coming in all the time. It's just through the daytime we can't see it. It's estimated that even at this rate, it would take about 160 trillion years for the Earth to add about 1% to its current mass. Now, the colour of the tails of these comets can also give us a clue to some of the chemical composition. If they're iron, which most of the comets do contain a large amount of iron, the tail will be a yellow colour. If there's magnesium or calcium or other materials on the surface, then the tail will take on a colour characteristic of the elements that exist in that particular comet or meteor. Now, large meteors may come from the asteroid belt rather than just randomly drifting around through space. We've probably heard of the asteroid belt, which lies between the orbits of Mars and Jupiter. Now, it was formed about 5 billion years ago, and it's thought the reason it didn't form a planet is because of the huge gravity from Jupiter, which prevented any planets from forming as the smaller stones began to come together to form something larger. Jupiter's gravity would pull these apart, and so it prevented any planet from forming in this region. Now, the largest object in the asteroid belt is Ceres, and it's about 950 kilometres in diameter. If we were to bring this carefully down to the surface of the Earth, this single stone would stretch all the way from Melbourne to Sydney. So there's three main types of meteorite. There are iron meteorites. If we were to cut an iron meteorite and polish it and treat it in a particular way, we will see an internal crystal structure, something like this, what's called a Widmanstätten pattern. This is named after the scientist who first discovered this. Now, in order to get iron crystals to grow to the size where they are visible to the naked eye, we need to cool molten iron very, very slowly, at a rate of approximately 1 degree every million years. If we were to look at the internal structure of a stone meteorite, we'll often see small little, what they call chondrules, tiny little round balls of material, and these have all come together to form the meteor itself. But they also contain a relatively large amount of iron as well, 5 to 20%. And so even stony meteors are actually magnetic. If you pick up a stony meteorite and put a magnet next to it, it will stick. If you pick up a stone that you think is a meteorite and it's not, chances are it will fall off. If it does fall off, the term for this is not meteorite, but it's a meteorong. Now, if you can imagine a large planetary body, perhaps several hundred kilometres in diameter, with a solid iron core and rocky material crust like the Earth around the outside. As you go from the rocky crust on the outside to the iron core in the centre, you'll reach a point where, rather than being all stone or all iron, it will gradually increase in percentage of iron, and so you will end up with a small zone where there are stones embedded in the iron. This is what they term a palisite meteorite, and they are the rarest of all the meteorites because there's only a very small area of the meteor where this particular transition zone occurs. But not all meteorites come from the asteroid belt or the remnants of comets, or even just random specks of dust floating in space. Anyone that's looked at the surface of the moon through a telescope, the first thing you notice is there are lots and lots of craters. Now, these are created when meteors have hit the surface of the moon, and if the impact is great enough, they may actually throw some of the material from the surface of the moon into space. Basically, it will reach the escape velocity of the moon. This material may float around for many, many years, but because the Earth is quite close and the gravitational attraction of the Earth is stronger than the moon, some of these may actually be brought in through the atmosphere of the Earth and land on our surface. Now, you might think this is actually quite unlikely, but a number of meteorites have been found, and when they are analysed, they do not have the same composition as normal meteorites that we've found that have come from the asteroid belt, but they have a very, very similar composition to rocks that have been returned from the moon, indicating that that is the place of their origin. They also don't have very much elemental iron, and so they're not magnetic. If you hold up a meteorite from the moon and a magnet does not stick, it may come from the moon. So having a stone land that has been thrown up at some time, perhaps millions of years ago, from an impact on the moon, obviously doesn't happen all the time. So they are actually very, very rare. To give you an idea of how rare, we've dug approximately 90,000 kilograms, that's 90 tonnes, of diamonds. The Apollo missions returned almost 400 kilograms of stones and rock from the surface of the moon. But in total, we've only found 46 kilograms of lunar meteorites, the largest being 14 kilograms. So you can see a very large proportion of all of the meteorites we've found from the moon are in one single stone. To give you an idea of how valuable they are, a meteorite from the moon is worth about $2,000 per gram in comparison to gold, which is about $40. So meteorites from the moon are worth many times their weight in gold. Now, if you've looked at pictures of the surface of Mars, you may have noticed that Mars is also littered in craters, similar to what the surface of the moon is. And it also has a very thin atmosphere, so any rocks thrown up from an impact are unlikely to be slowed down by Mars's atmosphere, and so they can be thrown into space as well. And as they slowly drift towards the sun, if the Earth happens to pass at the right time, these rocks may enter through the Earth's atmosphere and land on the surface of the Earth. Now, when we analyse these stones, we find that they're actually very, very similar to the rocks that have been measured by various rovers on the surface of Mars. So we know the origin of these is not from the moon because the composition is completely different, but they're very, very similar to the rocks that we've found on the planet Mars. And they're nothing like the rocks that are in the area where these stones have been found. So how common are stones from Mars? Now, interestingly, we've actually found 94 kilograms of stones from Mars, which is considerably more than what we have found from the moon. The only reason being we've actually found a number of fairly large samples, and we just happen to have found more at the moment from Mars compared to the moon. There's no reason to expect that Martian meteorites should prefer to land on the Earth versus meteorites from the moon. Now, when they enter the atmosphere, they come in perhaps 100 to 200 kilometres above the surface. And so because they are so far away, we don't actually hear any sound. It can take a considerable amount of time for sound to travel 100 kilometres from the atmosphere when they enter. However, we'll see them once they begin to compress that air in front and make it glow white hot. So we will see the meteors enter the atmosphere in dead silence, no sound whatsoever, unlike what you will see on the movies. So you will see a bright light, total quietness, no sound whatsoever. Some may be so bright they may even light up the whole area. Some have been witnessed to leave large smoke trails behind, which may be visible for several minutes. You can see in this picture the trail actually isn't straight, even though the meteor would have travelled in a straight line. But the winds up at the altitude of 100 to 200 kilometres have actually pushed this smoke trail around, creating a curved pattern when the actual meteor came in a perfectly straight line. Often, if the meteorite is quite loud, it may explode with a bang as the final pieces can no longer hold together. Some witnesses have even heard a tumbling sound as the meteorite has come in. Obviously, it's been, rather than coming in straight without spinning, it has been tumbling sort of like a football as it enters the atmosphere, and people have heard a woof, 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 woof sound as the sound from the meteorite has hit the ground. Now, as I said, it could take quite some time for the sound to reach the ground. This is from a side view of the meteorite that landed in Russia a number of years ago, and you can see it entered at an altitude of some 90 kilometres, and at even a height of 30 kilometres it basically exploded and continued on, and only small pieces landed on the ground. But at this sort of height it could take quite some time before the sound actually reaches. This is a video taken from a number of car cameras and security cameras from around the area of Chelyabinsk. You'll see it entering the atmosphere, but it would be in total silence. There would be no sound whatsoever. You can see now it's largely disappeared and has exploded. This is some footage from other areas. You see how bright it was. It was brighter than the sun. You can see it streaming off into the distance, the massive cloud of smoke it's left behind. Now this is a person, he could hear the commotion. He went outside with his video camera and filmed the smoke, but of course the sound hasn't reached the ground yet. So this is in total silence. And then the sound hit. And you will hear a series of explosions as individual pieces finally exploded, like machine gun fire. The impact set off a number of car alarms in the area, broke windows. Now when these meteorites land, if they're large enough, more than 10 kilometres, they may not actually burn up in the atmosphere. And they're large enough to create a crater in the ground. This is one in Arizona. This was one of the first meteorite impact craters to be identified as such. So what if one was to land in my backyard? This is an image you can see. It's taken a number of years ago now, in 1992, in an area in the US. Now back then not many people had cameras. There were no video cameras in your phones. Phones only made phone calls. But a number of people captured this as it was coming in. You can see it was breaking up into a number of individual pieces. Again, total quiet. There would be no sound. And this streamed across America and landed finally in an area of New York and hit this person's car. Now, they parked their car last night, and when they came out in the morning, there was a great big hole in the back corner of the car and a large stone sitting underneath. Now, they purchased the car originally for about $400, so it wasn't worth very much. However, after being hit by the meteorite, it makes it much, much rarer. And so they sold it at an auction shortly after the impact for $10,000. Now, back in 2020, a man posted an image that supposedly showed a meteor that had landed in his backyard. It had created a crater and there was a fire. Now, this is a very obvious fake to anyone that knows even the slightest about meteor impacts. Firstly, the object was far too small to create a crater. It would have to have created a crater much, much bigger than this. It was also not magnetic, and real meteorites don't cause fires like this. Also, if you actually watch this video, and you can Google it, it's really, really bad acting. So when a meteorite comes in from space, they're actually cold when they land. They've been out in space for perhaps billions of years, so they're at the same temperature of space in our solar system, but they only take a few seconds to reach the surface. Now that's not enough time even for the heat from the compressed atmosphere at the front to increase the core temperature of the object itself. So if you were to see a meteorite land in your backyard and you were to pick it up, rather than get burnt, you would be more likely to get frostbite. And people have seen meteors shortly after they've landed and noted that they are covered in ice and very, very cold to touch. So whatever meteorite hits you, how likely is it that you're going to get hit by one? Now, back in 1888, there was actually a series of letters that were written to the local governor and sultan of an area in Iraq. And they were translated recently, and they documented a case of a rock falling from space that had hit and killed a man, and another person was actually hit and was paralysed from the impact. Now, this so far is the only documented case where a person has definitely been killed by a meteorite impact. In Alabama in 1954, a woman was taking a nap in the afternoon. She went to bed and pulled the doona up over her to have a little nana nap in the afternoon. And she heard a loud bang in her house. And then suddenly something hit her on the side of the hip. Now what had happened is a meteor had come through the roof of her house, bounced off a radio, through a couple of rooms into her bedroom and hit her on the side of the hip. Fortunately, the doona, I guess, made the bruise much less than what it would have been, but you can see from this image that must have hurt. Now, ironically, they also happened to live opposite the Comet Drive-In Theatre. Now, this particular meteorite is now on display at the University of Alabama if you want to go there, and you can see it. 1972 in Trujillo in Venezuela, a farmer heard a loud boom sound overnight, and when he got up in the morning, he went to check on his stock and found a cow that had had a pulverised neck and shoulder and a large rock sitting nearby. This was also a meteorite which had hit and killed one of his cows. In December 1984, actually, a woman came out to check her mail only to find that the mailbox had been hit by a meteorite overnight and almost totally destroyed. Now, this particular letterbox was actually auctioned in 2007 and sold for $83,000. That's about more than 100,000 Australian dollars for a battered letterbox. In 2002, in North Yorkshire, Siobhan Cowton was getting into her car and something hit her on the head, and she bent down and saw this small stone. This was actually a meteorite. In Germany in 2009, Gerrit was on his way home from school when a small object hit him on the back of the hand. It was about the size of a pea. This was also a very small piece of meteorite. So can you collect meteorites at home? There's several ways you can collect them. One way is to go to the beach, get one of those very strong rare earth magnets and place it inside a plastic bag, and then drag this bag around the sands of the beach. Any meteorites that have landed on the beach or washed up onto the shore will be attracted to the magnet through this bag. You can then remove the magnet out of the bag and drop these small particles, these meteorites, into another bag for your collection. Alternatively, you can do the same thing, place a strong magnet inside a plastic bag and climb around your roof and collect any pieces of meteorite that may have landed on the roof. Alternatively, you can attach a bag inside the downpipe to your gutters and then just wait a few months as the rain slowly washes the tiny meteorites down off the roof into the gutters and down past your magnet. After a few months, you can then take these small particles off the bag by removing the magnet. They'll then drop off. However, you may need to use a microscope to see your meteorites. Alternatively, but you probably may need a permit to do so, you can go to an area where there is a recorded impact and fossick around there in an area called a strewn field. And you might find a few bits and pieces, some stones that perhaps look like they're a little bit burnt. The easiest way to check whether it could be a meteorite is to see if it's magnetic. Now, some people actually search for their meteorites with a large rod hanging off their shoulders, and meteorites hanging down, or magnets hanging down off strings. And they then walk through the area dragging these magnets across the ground, and the magnets then attract any meteorite remnants that may be on the surface. If you find what appears to be a burnt rock, particularly in a strewn field area, and there are virtually no other rocks in the area, this may quite possibly be a meteorite, particularly if it attracts a magnet. So where have these impacts hit the Earth? This is a picture of various places around the Earth and where impacts have been recorded. Perhaps one of the best well-known impacts is in an area called Campo del Cielo, which is in northern Argentina. Now, most people who have a meteorite collection begin with a sample from Campo del Cielo because it is perhaps the easiest to obtain. You can get quite large samples, even of the order of many kilograms. Now, it's believed this happened about 4,000 years ago, but as the meteorite came in, it must have exploded because rather than one impact crater, there's actually 22 individual craters in the area, the largest being about 50 metres in diameter. Now, iron meteorites, we've found perhaps 100 tonnes of iron meteorites. The biggest is 37 tonnes of this particular impact. The first samples were found by the Spanish in 1572, although the locals had used it for many, many years for making iron tools. The mythology in the area says that the holes in the ground were created by stones that fell from space, and the name Campo del Cielo actually means the field of the heavens, indicating that it's a field of where stones had come from the heavens. So what about impacts in Australia? Goss's Bluff, which is 175 kilometres from Alice Springs, is believed to be an impact from 142 million years ago. Now, this is 20 million years or more before even the dinosaurs. Now, this has become so heavily eroded that originally it was believed to be some 22 kilometres in diameter, but is now eroded so only 5 kilometres of the original impact remains. Local mythology says that it was created by a group of women dancing in the stars, and one placed their child in a basket, but the basket fell to ground and it created the impact site. Mundrabilla, near the South Australian border, is believed to be about 1 million years old, and about 22 tonnes of this particular one have been found over the years. Wolf Creek, near Halls Creek, is another well-known area, perhaps more so for the movie than anything else. Now, this was actually named after Robert Wolfe, so its spelling has an E on the end, and this is believed to be some 300,000 years old, and it's 800, almost 900 metres in diameter, first discovered in 1947. However, the local mythology says that it was formed when the rainbow serpent crawled out of the earth. Another myth is that it was the evening star, which is Venus, had approached so close to the crescent moon, but it got so hot that it then fell to ground. Henbury Crater, just out of Alice Springs, is believed to be about 4,000 years old, and it consists of 14 craters between 7 and 120 metres in diameter. This was actually the first crater that was identified in Australia. The local significance says that it was a fire devil that came from space and made its home on the earth. Another says that it was a lizard woman who was digging holes in the ground, and the material from the craters was the material that the lizard woman had dug up while she was digging the holes in the ground. Murchison in Victoria in 1969 was also subject to a meteorite impact. Now the locals said when they saw the stones, which were strewn all over the area, that it had a very characteristic smell of kerosene. Now this is some pictures of some that children had picked up and taken to the local school and council and laid out on the ground here. You can see how many pieces people had found and the variation in the sizes. Now they even named a street after the impact as well. Now the Murchison meteorite itself is actually very, very unique in itself. They've identified more than 100 amino acids, and tests in 2010 showed it contained some 14,000 different chemicals. But again, it also has a very high percentage of iron, so if you were to place a magnet near it, it would be attracted. It also had 12% water. Now some of these samples are now worth about $2,000 per gram. Now this particular child is probably well into his 60s or 70s now, and I think he's probably wishing he kept this stone, because at $2,000 per gram he's probably holding many, many hundreds of thousands of dollars of meteorite. As a local impact, the Cranbourne meteorite was thought to have landed somewhere around 1770. So at that time the area was actually occupied, and so it is believed that it was probably witnessed, so people would have seen this impact. However, the area in which it landed was very wet and very marshy, so rather than creating a crater, the meteor simply slipped into the mud and disappeared. When it was first found, it was actually the 11th largest in the world, and the first sample weighed in at 3.5 tonnes. Now it was first mentioned in 1854 that some of it had been found, and they've also found fragments in Cranbourne, Pakenham and Beaconsfield as well since then. Now local cultural significance is that the locals would dance around the stone and hitting it, remarking at the metallic sound that it would make. It was also used as a fertility symbol. Now replicas used to be on display at Cranbourne Park, however I believe this display has now been dismantled. A number of people had stolen the copies that were hanging down from the structure here, believing they were actually real meteorites, when in actual fact, of course, they're not. So all of these have done relatively minor local damage, nothing highly significant. So what if a really large meteorite was to hit the ground? Something perhaps 10 kilometres in diameter. Something of this size, if it was sitting on the ground, would be just at the height that an aircraft reaches when it is at cruising altitude. So you imagine if you were flying to America or Europe or something, the height that the plane gets to at its maximum would just clear the top of a stone of this size. Something like this would weigh about 34 billion tonnes, 10,000 times the weight of Ayers rock. The heat from the impact would be approximately 20,000 degrees Celsius. The surface of the sun is 6,000 degrees. Travelling at 10, perhaps even 20 kilometres per second, it's 10 times faster than a speeding bullet. So fast even Superman wouldn't be able to catch it. The amount of energy released from the impact would be approximately 100 million megatons. If this was to land in the centre of Port Phillip Bay, the energy released from this impact would instantly boil all of the water into steam in Port Phillip Bay, 50,000 times over. Or if it was in Sydney Harbour, 2 million times over. The crater would stretch basically from Ballarat all the way to Warragul. So if you were standing on one rim of this crater in Warragul, you would not even realise that you were standing in a crater, because the other side of the crater would be so far away, it is on the other side of the curvature of the Earth. It would just disappear over the horizon. The material thrown into the atmosphere would actually darken the skies for several years, and so it would remain dark for years and years. Now they discovered that there are various areas in the world where there are fossils of dinosaurs in particular, but other animals, that were plentiful at one particular point, and then as they go up through the layers, there was a dark black clay-like deposit, and on the other side of that deposit, many of the animals that were seen in the lower layers no longer existed. Those particular animals had gone extinct. Probably the most well-known, of course, being dinosaurs. Now, when they examined this particular clay material, they found that it contained large amounts of iridium and platinum, which are not very common in the surface of the Earth, but they are very commonly found in large meteorites. Now, as they measured the thickness of this layer, they found that as they got closer and closer to Mexico, to the Yucatan Peninsula, they saw that this deposit got thicker and thicker. And as they left the Yucatan Peninsula, it began to get thinner and thinner. As satellite imaging became more prevalent, they were able to determine that in this area there are the vague remnants of a crater. They have also done a number of core samples in this area, even some very recently in the last couple of years, and they have noticed that there is a layer of rock that has been cracked, smashed and crushed, which is consistent with the meteorite impact. When they date how long ago this must have occurred, they come to a figure of about 65 million years, which is also coincident with the time when the dinosaurs appeared to become extinct. So at the moment, this is the current theory as to what caused the extinction of the dinosaurs. So when is the next large impact like this? Now, the sun orbits the centre of the Milky Way, but if we look at it edge on, it actually wobbles up and down like a cork on the waves of an ocean, and every 60 million years it passes through the plane, and it's thought that as it passes through this area, the likelihood of meteorite impacts does increase. Now, interestingly though, we passed through this area about 5 million years ago, so perhaps we're 5 million years overdue for the next large impact. So if anyone has any other questions, please feel free, but thank you for listening to my talk.
I've just got a question has come through. What locations on Earth were the lunar meteorites found? They've actually been found in a lot of locations. My particular lunar meteorite, I'll hold this up to the the camera, and you'll see, if I can get the reflection out of the way, it's about the size of a fingernail. And this was actually found in Libya. So this particular stone from the moon was found in Libya. A lot have also been found in the Arctic and the Antarctic. Now, the reason, actually, a lot of the Martian ones have been found there as well. The main reason why areas like the Sahara and Arctic and Antarctic appear to have a lot of meteorites is because there's nothing much there. So you imagine if you're in the Antarctic and you've got nothing but ice for miles and miles as far as you can see, and there's a rock sitting there and it's got some burn marks on it, and there's no other rocks anywhere, then it's quite possibly a meteorite. And it just happens that we have found quite a few from Mars and from the moon in these areas. But in general, there's no reason why they wouldn't be found even in Australia. But I'm not actually aware if there are any Australian Martian or lunar meteorites that have been found. Most, as I say, have been in the more easily accessible areas like the deserts and the Arctic and Antarctic. Now, I've got another question here from Sienna. Would scientists be able to tell if a big meteorite was coming towards the Earth? There are actually a lot of telescopes that are constantly looking up in the skies all the time. NASA has a number of projects where they're constantly taking images of the skies, and then they can compare the images maybe 1 or 2 days later and see if something's moved. And if something's moved, if it's not a planet or something like that, then they can determine whether it's an asteroid or a meteor or something like that. And after a few observations, they can determine fairly accurately the orbit and whether it's likely to hit us. So we don't actually know if there's anything coming our way, but at the moment, there's nothing we're aware of that that's a problem for at least the next couple of 100 years. Now, that video of the impact in Chelyabinsk in Russia, we didn't know that was coming because that actually came almost in the same direction as the sun, which makes it almost impossible to see because you can't direct any telescopes or anything in that direction and expect to see a meteor. So there could be something coming. If it happens to come from the direction of the sun, we would not know that it's coming. But statistically, most of them will come from another direction, so they should show up in surveys. And at the moment, there's nothing. Next question here. Jess has asked me, have I found a meteor? Yes, I have found a number of meteorites. I found this particular one on a website from a meteorite dealer in Arizona. Okay. Yep. So this is a meteorite that, well, yes, I did find it, but I found it on a website from a meteorite dealer. Now, I might have to stand up to show you this one. This was a particular meteorite that was on one of my slides. This is a Campo del Cielo, right? And you can see how big it is, right? It actually weighs 11 kilograms. And if you look carefully when you saw the picture, you would have seen that it looks amazingly like Australia. And as a result, I call him Aussie. So he's if you come to a viewing night at MPAS when we get back to normal, and I'm doing a talk on meteors, I will have that one with me, and you can actually come and hold it and feel just how heavy it actually is. So as for finding meteorites on the ground, no, I haven't. All of my meteorites I've purchased from proper meteorite dealers. If you get them from cheaper places, it's quite possible that you haven't actually bought a meteorite. You've bought a meteor wrong. You've bought something that's fake. Another question. Would it impact would it would it impact the whole Earth if a meteorite that wiped out the dinosaurs was here again? Yes, it would. If a similar impact happened now and we had no method of stopping it, and at the moment we have very little that we could do, yes, we would probably be wiped out just like the dinosaurs were, for the very same sorts of reasons. Okay, another question. So Christo asked, if lunar meteorites are not magnetic, what distinctive features do they have to distinguish them from magnetic meteorites? Well, I guess if you found either a lunar or a Martian one, because they're not magnetic, the only giveaways they would have is that they would have burn marks, possibly on the outside. They wouldn't be magnetic, but they would be in an area where there has been a meteorite impact of some sort. So if you thought you had found a lunar meteorite, you would probably need to send a sample of it to a museum or something to have it evaluated, because there would be no definite way to tell that it's not from the moon, other than the fact that if you just found it in your backyard, the chances are you've found a rock that's fallen out of someone's barbecue, and hence the scorch marks, because they're incredibly rare. From Jack, if we find a rock, do we find out if it's from space because of its iron content? In general, if it's not a lunar or Martian meteorite, it will have a very large iron content. So if I pick up this, which looks just like a normal everyday stone, and a magnet, you'll see that it sticks. Now, if I just picked a rock up out of my backyard, that would not stick. It would fall off. So if you pick up a rock, and particularly this one has some burn marks, which I think you can see here, then, and the magnet sticks, it's a possibility that it is a meteorite. So, so that's sort of one way you can find out if it's a meteorite, because it has a fairly high iron content. However, if you're in an area, particularly in Europe and the UK, they have a lot of areas where there were bombs from World War II that exploded, and there are fragments of metal which may have scorch marks. And of course, they attract a magnet because they're almost solid iron, but they most certainly are not meteorites. They're just remnants from a bomb explosion. If someone found a real, reasonable sized meteorite, would they need to declare to someone that they found it? It's interesting, actually. Peter might know a little bit more about the legalities of this, particularly in Australia, but if it lands on Commonwealth, there's a big difference between if it lands on Commonwealth property or private property, I think, isn't it, Peter?
Well, the issue if it lands on Commonwealth or Crown land property is that, of course, no one sort of owns it other than the Crown. The rules vary a lot from state to state, and certainly here in Victoria, it's a case of if a meteorite lands on your property, for example, then you own it, and you may indeed choose to donate it to your local museum, for example, and in some cases the museum may even cut off a little piece for you to actually have and to own. But some of the states, particularly for example in the Northern Territory, if you come across a meteorite, say you go and visit Hembury Crater and that no, you don't actually own it. It belongs to the Crown. Yeah. It's also, in Australia, it's also illegal to sell meteorites overseas unless you have a permit for it.
Yeah. Brad asks, are there theories on the origins of Murchison meteorite? The thing with the Murchison, I don't think we've had any falls that are the same, have we, Peter? It was totally unique. There's never been another piece of meteorite like Murchison that's landed anywhere that we're aware of, is there?
Correct. And if you want to see a bit of Murchison, I don't know if you can
Yes, I can see it.
see
Yeah.
that on my screen there. That's about 0.5 grams worth.
Right.
And as you see, there's no silver shiny. It looks black like soot or carbon. And indeed, that's what it is. It's known as a carbonaceous chondrite. Now, that's barely the size of a small fingernail in size. And the pictures that Trevor showed in his talk were much, much larger than that. And no, I've never broken it open to see if it smelled of kerosene either. I think it was actually thought that it came from the original solar nebula. So
Right.
the very large meteorite that Trevor showed before, where he held up the one that he called Aussie, the really, really heavy one, that would have come from the asteroid belt.
Yeah.
But Murchison is thought to actually come from the material that was there before the planets even existed. So in other words, it's even more ancient than the ones from the asteroid belt. And that's what makes it very unique. There's very few of those found today.
Yeah. Treya asked, why can't we see comets and meteorites in the daytime? Well, for the same reason that we can't see the stars other than the sun. Through the day, when the sun's shining, the stars are still there. They're not the ones you would see when the sun sets. They would be the ones that you would see at night time, maybe 6 months later. But the reason we can't see the stars and we can't see meteorites through the day, unless they're very, very large, is that the sky is just too bright. There have been, of course, many cases like the one in Chelyabinsk where you could certainly see it through the daytime because the meteor itself actually glowed brighter than the full sun anyway, but these would be very rare examples. Usually they would only be quite small when they come in, and so we wouldn't see them. Next, there was another question down here. Just got to scroll down. Oh, bear with me. Could a meteorite have living organisms in them? This is a theory they call panspermia, isn't it? Where they believe that it's possible that maybe even life on Earth came as a result of a meteorite impact that's carried living organisms from somewhere else to this Earth. There's no proof that that's what happened, but that is a theory that how life could go from one planet to another. A thought is that there could be perhaps Earth life, maybe on Mars, or maybe Martian life on Earth as a result of meteors being thrown between one planet and another. So it is possible they may have living organisms inside them, but at the moment we haven't found anything. How big does a meteor have to be a crater? From Jack, around about 10 metres. If it's more than about 10 metres in diameter, then unless it's actually weak, like with a lot of cracks or something, it's quite possible that it won't all burn up in the atmosphere and something will hit the ground. But if it's not particularly large, it might just be like a stone has dropped out from a helicopter or something and just gone clonk on the ground and not actually make a crater. But the ballpark is more than 10 metres in diameter, so much, much bigger than a car. Otherwise, it would just burn up completely. Another question from Chris, were any fragments recovered from Tunguska? Not that I'm aware of. They haven't, have they? Only the results of the impacts, because they don't know. They're not sure whether that was possibly a comet, in which case it'd be probably less likely, or a meteor or anything. We don't really know what Tunguska was, do we?
Yeah, I'm not aware of any.
Yeah. Can meteorites be radioactive? Yes, they could be. I'm not aware of any that have landed. There's no reason why they couldn't have small amounts of radioactive material in them, but they certainly wouldn't be radioactive and dangerous to that degree that they wouldn't have any more radioactivity, I think, than just the surrounding rocks that that we walk on every day. Treya asks, what and where is the asteroid belt? The asteroid belt is that area between the orbits of Mars and Jupiter, and that's where most of our meteorites come from, and there's probably millions of individual objects. The largest, as I said, was Ceres, which is nearly 1,000 kilometres in diameter. But if you were to take all of the material from the asteroid belt and put it together to make one whole planet, it would be about 1/3 the size of the moon. So it would be still incredibly small. So it's a big area with a lot of pieces, but it's not actually a huge amount of material. Is the Earth, so a rare earth magnet that you use to find meteorites, a special type? Yes, to find, like I said, to find meteorites on the beach or on the roof, you place a strong magnet inside a plastic bag. Now that needs to be one of those very, very strong magnets, what they call a rare earth magnet. So it needs to be very, very strong. And then you can probably get those. I would have said Dick Smith or somewhere, but he's not around anymore. But some of those places, I'm not sure exactly where you would get them, but very strong magnets. You might get something with a very strong magnet at Bunnings, perhaps, like a magnetic hook, and then use maybe 2 or 3 of those together to get enough strength, put inside a plastic bag, like a freezer bag, and then you can just drag that around at the beach or somewhere like that, or as I say, leave it in a plastic bag in the downpipe of your house, and over the next few months, the rain will slowly wash tiny meteorite fragments out of the atmosphere onto your roof, down the downpipe, and the magnet will catch them as they go past. So yes, it does have to be a special magnet, one of those very strong ones.
You can definitely find the rare earth magnets on eBay, and you can get them within Australia, so you won't be waiting for a package to come from overseas. All you need to do is either search for rare earth magnets or neodymium magnets.
Yep.
And some of them are very strong. They make them with hooks attached, so that inside a metal garage, you can actually attach a hook that will hold up to 60 kilograms just from the strength of the magnet that is gripping onto the wall of the garage.
Yeah. Yeah, where I used to work about 10 years ago or 15 years ago, we were using rare earth magnets for holding things on shelves, and we had to order like several thousand of them, and they were not allowed to be flown. They had to come out by ship because the magnetism was so great that they weren't allowed to fly it. It had to come out by ship, and these were very tiny. They were about the size of the end of your index finger, but if you got 2 of them together, they would pinch your skin to the point where it would just nip the skin off the end of your finger and you would just bleed. So you had to be very, very careful with them. Right, Jack has asked, what gives a falling meteorite its colour and brightness? So the colour, generally they'll be yellow because that's the sort of colour that iron creates when it's burnt. So the constituents of it, particularly iron, because there's a lot, but other chemicals like calcium and magnesium will give a characteristic colour to the tail. And the brightness is just as they enter the atmosphere, compresses the air to the point where it just glows white hot. And that's what you see when it comes through the atmosphere, and that's what gives it the brightness. I've done that one. How big would it? James asked, how big would a meteorite need to be to destroy the planet? It would need to be very, very large. Perhaps something the size of Ceres would certainly make a lot of damage to the Earth, but like the one 10 kilometres in diameter that wiped out the dinosaurs, it wiped out the dinosaurs, but it didn't make any long-lasting effects on the Earth itself. So it would need to be incredibly big, perhaps Ceres size or even bigger, to do physical damage to our planet. They believe actually the moon was created when the planets were forming by a planet roughly the size of Mars impacting the Earth, and that's what caused the creation of the moon. So something the size of Mars would be sufficient to disrupt the Earth to the point where it would split off another object. So yes, it would have to be incredibly big, and something like that we would certainly see. James asks a follow on, how big would a meteorite need to be to create an extinction event? And how likely is a near object to collide with the Earth? Well, to create an extinction event, the one that wiped out the dinosaurs was about 10 kilometres. It probably didn't need to be that big, but anything less than about a kilometre is probably sufficient to wipe out a city, maybe, or smaller, maybe a suburb, but anything less than about a kilometre would do nothing more than severe damage to wherever it hit and would hardly create extinction of life as we know it. So it would have to be at least 10 kilometres or so. Christo asked, hard disk magnets. I don't understand the...
Probably a question on the rare earth magnets.
Oh, right, yeah. So, yes, again, with the rare earth magnets. Treyer asked, what are bolides? Bolides is just a term for very large meteorites. So most of the ones, if you go out late at night and if you're in a darkened area, you might see a few streaks across the sky. What you're looking at is something that is perhaps the size of a grain of sand or smaller. So incredibly small. What you're actually seeing is not the object itself, but the glowing air in front of it. Bolides would be something quite a bit bigger, like the size of a stone. They would be bright enough when they come in. They won't make it to the ground, but something the size of a stone would be sufficient that if you were nearby, it would light up the whole area like someone has turned on a massive floodlight. And that just from something about the size of a stone that you would just see, on the side of a road or something like that. So that would be termed something like a bolide, or even bigger, perhaps even the size of a basketball. But it wouldn't be anywhere near big enough to make a crater. David asked, what are the lines in the meteorite? I believe he's talking about the Widmanstatten. You've got your Widmanstatten pattern, have you?
There's a bit there.
Yes.
That's the same meteorite that you held up, but that's what it looks like inside. If I can get the light to shine on it, you'll see those lines. Yeah,
you can see the light and dark areas. Those lines are actually just the crystalline structure. The chemical process they use when they cut it highlights the crystalline structure itself and shows up as lines, or like in the case of what Peter's holding, you can see each of these large darkened areas are actually individual crystals of iron. Now, normally a crystal of iron is so small you'd need a microscope to see it. But if you cool it slow enough, like I said earlier in the talk, about 1 degree C per million years, it gives the iron long enough to actually form crystals. You may have done an experiment. I did one in school where you get the copper sulfate solution and you hang a little copper sulfate crystal, and as the water slowly evaporates, the copper sulfate crystallizes onto that and it forms a large crystal. Again, just from the water evaporating very, very slowly. And the same case with the iron, that it solidifies very slowly. It would take millions and millions of years to turn from molten iron into solid iron, giving it enough time to crystallize. So Treyer asks, where did you find your meteorites? I got my large meteorite from a company in Arizona called Arizona Skies Meteorites. I have nothing to do with them, but they sell large meteorites on the internet. They also sell dinosaur fossils, so they sell T-Rex teeth and other dinosaur skulls and bones, various sorts of meteorites. So I bought some of my meteorites from there and a lot of my others from a guy in the UK who also sells meteorites. I got my Martian and lunar meteorites from him in the UK, called Space Rocks UK as well. But a number of if you just Google it, you'll find a number of dealers who sell meteorites. There are also dealers in Australia as well. So if you want to get something local, which will be a lot faster for the delivery. I can't remember the name of, what's the one? There's an Australian.
There's one in Dandenong called Rocks on Fire, I think.
That's the one I'm thinking of. Yes, yes. He's probably the closest around in this area. Yeah.
And here's a bit of the Cranbourne meteorite that you mentioned a little bit earlier. Not sure if that shows up clearly. Yes. And you can see it's got those lines inside it as well.
Yeah, the crystalline structure. Yeah.
Do we have any other questions? Oh, there's one there from Nadia and Isabella. One moment while I copy it over.
Okay. Nadia asks, last year I saw a vivid green fireball, just as in your slide, which appeared to land next door with that brightness. Could it be 10 kilometres away? Where that video was shot of that one in America, at that time it was probably at least several kilometres up in the air. So it possibly would have landed 100,000 kilometres away, even at that sort of height. So if you see it go overhead like that, chances are it's not going to land in your suburb. It will land a very long way away because it will be very, very high in the atmosphere still at that point. What would I find in the middle of a meteor crater on Earth? You would expect that you would find part of the meteor, and in most cases you will. But it's interesting, that first one that I showed the picture of in America, that was actually the first thing that was found to be a meteorite impact crater. Initially, they thought it was the remnants of a volcano because it's in an area where there is a lot of volcanic activity. But when they did determine that it was, in fact, a meteorite impact crater, they figured that if they dig in the middle, they'll find a piece of it, and they have dug, and they've never found it. It would appear that that particular crater in Arizona wasn't so much formed when the meteorite hit the ground and exploded, but they believe the meteorite actually exploded just above the surface of the Earth, and that hole in the ground is just the shock wave from that explosion rather than an impact. A lot of other impact craters where the item actually made it to the ground, yes, you will find very large pieces of the meteor in the centre of that crater. But in the case of Arizona, they've dug and they didn't, because it wasn't technically an impact crater. Treya also asked, when was the last lunar meteorite seen? I don't know. My particular one that I've got here, the one that I showed before, this one, it says that it was actually found in 1990. Now, it most certainly did not land in 1990. It's possible some of these could have landed 10 or even 100 years earlier. A lot of the ones in the Arctic and Antarctic could perhaps have landed many, many thousands of years ago. A lot of the ones that are found in the Antarctic have actually landed on the much, much closer to the centre of the ice shelf. And over the many, many years, the glaciers have slowly brought them to the edge of the ice shelf, and then the ice has sort of melted away and deposited a lot of those on the ground. So it's really hard to say when the last one was seen to impact, because when they're found compared to when they landed could be centuries apart. So I don't actually know.
And well, one interesting thing that the Apollo astronauts brought back from the lunar surface was that they brought back an Earth meteorite. Yes. They didn't realise it at the time, but there was a piece of Earth sitting on the moon, and they eventually determined that its origin was in fact the moon. So they brought it back to Earth.
Yes. Yes, I was thinking of that very thing when I was talking about the lunar meteorites and that. But yes, on the moon, Apollo actually found a piece of the Earth. They just didn't know it at the time.
And thank you very much, Trevor. For those that have not seen Trevor before, he does a lot of our public talks at the observatory down in Mount Martha, and he's travelled the world talking astronomy to people on board ships, at least when people could easily travel around on ships. And maybe you'll get back to that in a few years' time when we get free reign. Hopefully you'll see on the screen now the competition that we're also running, which gives you an opportunity to win your own meteorite. We have 5 meteorites to give away. They're actually related to the one that Trevor showed before, the great big Aussie one that was the Campo del Cielo from Argentina. These ones are not as large as that, obviously, but they're small cousins of exactly the same meteorite fall. The details are at that URL link shown on the top of the screen. If that's too long for you, just go to the MPAS Society website, so www.mpas.asn.au, and look under events, and you'll also see a link there which goes to the same place. And you've got until the 22nd of August to actually put in your guess as to, or your best estimate as to how many shooting stars actually impact the Earth in a given day. Okay, well, with that, thank you very much for joining us this evening for National Science Week, and enjoy any other online activities that you can actually find while we're going ahead in lockdown in various states.
Hi all, welcome to Groundhog Day Sky for the Month for August 2021. Once again coming to you from lovely Victorian lockdown. On to the highlights for August-September 21. You'll notice there's quite a few comets listed here. I won't go into too much depth on these at this particular time. We'll refer to them a little bit later in the presentation. For those who like looking at the planets, both Jupiter and Saturn are in ideal place at the moment, Saturn having gone through opposition earlier in August and Jupiter being at opposition on the 19th. For the newer members, opposition is the best time to view these planets because that's when they are at their closest to us. On the 22nd of the 8th we have a full moon, which of course will make viewing deep space objects just that little bit harder. Not impossible, but you can expect a bit of a light pollution from the full moon. The last quarter moon, and moon being at apogee or furthest point from the Earth, occurs on the 30th of the 8th, and the new moon on the 7th of the 9th. Of note on this list is Ceres. Now, Ceres is the largest object in the asteroid belt. It has been reclassified as a dwarf planet, there with Pluto and Eris, and it'll appear 0.9 of a degree south of Aldebaran. Now, Aldebaran is the brightest star in Taurus, so it should be fairly easy for most people with a reasonable sized telescope to find and have a little look at Ceres. On the 14th and 9th we have first quarter moon, and also for those who like looking at little blue dots, Neptune will be at opposition also on the 14th to the 9th. Looking at the August night sky looking towards the south celestial pole, you'll notice objects such as Eta Carina Nebula and the Tarantula Nebula in the Large Magellanic Cloud are fairly low on the horizon, and so may not be the best time to observe them. A little bit higher, you have both Omega Centauri and 47 Tucanae, which are extremely good globular clusters to look at. And because of their relative brightness, they're quite easy for people to find, even in modest-sized telescopes. Moving up the Milky Way there towards Scorpio and Sagittarius, which is galactic centre. You have things like the Lagoon Nebula and the Trifid Nebula. You also have a variety also of globular clusters in M22 and M4. Now M4 fairly easy to find because of its relative close proximity to Antares, which is a red giant in Scorpio. Looking towards the northern August sky, have a couple of interesting deep sky objects in particular. Got the two globular clusters there, M13 in Hercules, although maybe a little close to the horizon unless you've got a particularly good northern horizon. And over in Pegasus, a little higher up, is M15, another globular cluster. Looking at the Lyra, which is easy to identify with Vega being quite a bright star. You have the Ring Nebula, M57, and just up and to the right of that is M27, the Dumbbell Nebula. Moving further afield, or a little further up, you have the Wild Duck Cluster. It's more of an open cluster, not a globular one. Looking at the planets for the month, Mercury has moved through superior conjunction in early August. And given its speed, it'll move fairly rapidly into the evening sky, where on the 19th of the 8th it'll be 0.2 of a degree from Mars. Venus, now very obvious in the western evening sky. It is moving towards its maximum elongation east and is very easy to spot due to its brightness. This of course assumes the clouds will disappear and give us a view. Not much to report for Earth. Still continuing around the Sun at the speeds listed there. They are in miles per hour, which probably gives my age away. Looking now at the outer planets, Mars is very low on the western evening horizon as it moves towards its conjunction with the Sun. You won't see a lot of detail purely because of the distance between us and Mars at the moment, and it's not exactly the biggest planet out there. It is expected to have a conjunction with Mercury on the 19th of the 8th. Jupiter is now definitely an evening sky object in Aquarius, and it will reach opposition on the 20th of the 8th. It's the best time to view it, and in particular you're looking for the surface details of its bands, its red spot and configurations of the particular four big moons, and apparently something to look out for over the next few weeks, shadow transits. Saturn is also an evening object, just ahead of Jupiter in terms of rising and setting. It reached opposition on the 2nd of this month, and so is still in a very good position for observing. The rings are still tilted towards us, and as I pointed out last month, as we move towards what is known as the ring plane in March 2025, the rings will gradually close off and appear narrower until they don't appear at all. Uranus still in Aries, it's now viewable in the late evening, rising around about 11 PM. And Neptune, rising around 8 PM in the eastern sky, moves into opposition mid-September, and as per my earlier instruction, opposition's the best time to view it, particularly for those wanting to have a little look at a blue dot. As to the appearance of the planets, Mercury that's just come through superior conjunction will be showing most of the face we can see will be lit by sunlight. Of course, as it moves through its orbit, we start to see part of the black, dark rear part of the planet. Venus, still moving towards its maximum elongation, and so we're still seeing a large part of one side of it lit by the sun, as it moves into its maximum elongation, it'll be about half the planet visible. Mars, as I said, a little red dot. In all but the largest telescopes, not much detail. Saturn, always spectacular, probably the planet that got a lot of people into astronomy when they first saw it. Still has its rings tilted towards us, and over the next couple of years, as I said, you'll be able to watch those rings close. Jupiter, also very spectacular, and even through reasonable sized telescopes you can see the band details. You can clearly see its flattened appearance, and its 4 big moons are certainly worth looking for. Uranus, not much detail on Uranus, doesn't appear as much more than a modest or rather small greenish blue disk. And Neptune, I certainly can't say that any of my telescopes have ever showed it to be quite that size. On to the other stuff. As I said earlier, there's quite a few comets visible at the moment, although they are around about 9th to 11th magnitude, and so will require a telescope to be seen. Pons Winnicke has already passed through perihelion and is heading back out into outer space. Currently visible through the night in Phoenix, and is expected to fade from 10th to 11th magnitude. Comet DRS, visible in the evening sky in Serpens, ultimately moving into Ophiuchus, Ophiuchus being just near Scorpio. It is expected to remain about 10th magnitude. Comet Finley is a morning object in Taurus, moving into Gemini, and it's expected to fade fairly quickly from 10th to 12th magnitude, so not really sure how you go with Comet Finley. Comet Tuttle reaches perihelion in late August, so it's still on its way in. It'll be about 9th magnitude, so the brightest of them all. Very low in the pre-dawn horizon, so it may be a little bit difficult to see. And the last one, Comet Faye, rises about 1 AM in Taurus and will be around about 11th magnitude. It should brighten as the month progresses. Meteor shower, we're currently having the Perseids from the 17th of July through to the 24th of August. Unfortunately, the radiant for these meteors is below the horizon, but it's a fairly dependable shower with an hourly rate of around about 60 meteors per hour. And that concludes Sky for the Month for August 2021. Hopefully there was something there that you can get your telescope on and have a good time viewing. As always, tonight's information was provided by Astronomy 2021 by Wallace Dawes and Northfield. Hope to see you all next month in person. Thank you for tuning in, and bye for now.
These objects, they've been out there for billions of years, and then just by chance the Earth and this object intersect. One will be large enough that will survive the passage through the atmosphere, that fiery passage, and it falls onto the surface of the Earth. And what we can pick up is called the meteorite. Very few of the things that actually fall are found. My name is Laurence Garvie. I am the curator for the Center for Meteorite Studies at Arizona State University, and I'm also a research professor in the School of Earth and Space Exploration. Meteorites fall from space onto Earth all the time, and these are precious old objects. These are objects that tell us about our early solar system. We need a place to keep them sort of in a safe environment for future studies. And so the Center for Meteorite Studies is that place. This is a meteorite vault around us. Each of these meteorites really has a story locked up inside it, and our job as scientists is to unravel this story. Almost all the meteorites that fall are from the asteroid belt. When we look at the different types of meteorites, one of the most recognizable are the iron meteorites, because iron is rarely present on the surface of the Earth. It rusts. We now know that most iron meteorites are the cores of early asteroids. They're telling us about the formation of early planets. You sort of imagine early planets that were forming and failed. Then we have the chondrites. They really tell us about the most primitive early solar system material that have not experienced as a whole melting processes and high heating processes. If we think of one of the most famous ones called Murchison, which fell in Australia in 1969, and when you open this thing up, it's black on the inside. It's full of carbon and organic materials. That was telling you that the building blocks of life can form in outer space in an environment and at a time that was even earlier than the formation of the Earth. Actually, it's interesting, when you break open Murchison and actually smell it, it smells odd. And what you're smelling is 4.5 billion year old organic compounds that are still evolving from the sample. We have meteorites from Mars and we have meteorites from the Moon. Nature has impacted the surface of Mars, ejected materials off Mars into space, some of which can eventually intersect with the Earth. So nature has brought back samples for us, and those are called achondrites. And when we look at those, they are crystalline rocks. Some of the most beautiful meteorites that we have are called pallasites. If you look at them, there's this beautiful sea of gemmy green peridot crystals in a metal of matrix. And we think that they are telling us about conditions between the core of an asteroid, which is primarily metal, and the outside of the differentiated asteroid, which is primarily silicates. You know, every once in a while a meteorite lands, so to speak, in your backyard, and this happened here in the Phoenix area. This is once in a generation, a falling in our local environment. For lack of a better word, it exploded above a remote part of eastern Arizona. This was the first time I participated in a meteorite fall recovery. What we were looking for here was something that looked out of place. Because, you know, we were in high mountainous regions, there were pine forests, there were oak forests. This was a really remote site. We hunted for about 132 hours in total. As soon as you came across this rounded, black fusion-crusted rock on this reddish ground, it completely stood out. First thing we do is to lift it up, very excitedly, by the way. I mean, you cannot imagine the excitement of finding your first meteorite. This stone turned out to be really amazing. So when we looked inside, it had structures that I hadn't seen before. It has like a crushed texture to it. It has the chemistry of a chondrite. So what is this telling us? So now we're starting to do the scientific work. You know, what we do is we look at these meteorites and we look at their characteristics and their chemistry and their isotopes and their structures. And what we're trying to do is piece this all together to really unravel the early solar system story. When we look at our current solar system, why does it have, you know, the rocky planets near the sun, and then we have the asteroid belt, and we have the gas giants? How unique are we? We're always hoping for the next thing to fall, the next thing that's different and unusual.
This is Sean Blair reporting for EasterWeb TV. Humans have always had a surprisingly close relationship with meteorites. We've worshipped them, we've made tools out of them. Egypt's King Tutankhamun had a dagger made out of meteoric iron. We've even lived inside impact craters, as in the case of Nordlingen in Germany, with a church made out of impacted rock. And that relationship goes on to this day in the shape of this building here, the headquarters of the DCOS company, just across the road from ISA's Technical Centre in the Netherlands. Now, this building not only looks like a crashed meteorite, it actually has a real meteorite at its heart. Let's go take a look. And here it is, a sizable chunk of iron meteorite, slap bang in the middle of the DCOS offices. And the person who brought it here is the founder and owner of DCOS, Paul Vega. Why do you have a piece of meteorite in your office?
Well, we have a piece of meteorite here as a symbol for sustainability. We believe in a new society that will be digital and paperless and will be all sustainable. And we think this is a symbol of what sustainability looks like. This is 4.5 billion years old. So if we can make a sustainable society, we'll go forward as long as this goes backward.
And you haven't just set it in a location at random. It's placed in a very precise point of the building with a window up above.
Yes, we have the sun coming here once a year on June 21st, when the sun is at the highest point. It will hit the meteorite once. So it's our own mini Stonehenge kind of moment.
All right. And where did the idea come from to get the stone in the first place?
Well, it was actually Rob van den Berg from Space Expo that pointed us at the idea of when you have a building that looks like a meteorite, you should actually have a real one. And I was surprised that it is possible to have a real one, and I'm really happy to have it here.
Purchasing the meteorite was arranged with the help of Rob van den Berg, who joins us now. Rob's the director of Space Expo, ESTEC's neighbouring visitor centre, because actually it turned out that Paul didn't just buy one meteorite, he bought two. The other one is here on long-term loan, so the general public can go see and touch a piece of the solar system for themselves. So Rob, where does the asteroid come from?
Well, they come from Campo del Cielo, a location at Argentina, South America, where we already found more than 100,000 kilograms of the same asteroid that fell there probably 5,000 years ago.
What do we know about it? It's made of iron?
Yeah, it is iron. It's quite heavy. This piece alone weighs almost 70 kilograms. And you can see it's a meteorite because of what we call these thumbprints. They are caused by the wind blowing on the molten layer, the molten outer side. The asteroid hits the atmosphere, and then later it solidifies, and you still see the thumbprints. So you see at a glance it's a meteorite.
As the kind of caretaker of a meteorite, what do you have to do to look after it?
Well, almost nothing, because it's quite hard. It was corroded when we bought it, and we got rid of all the corrosion, so it got very shiny, and now it stays shiny because everybody can touch it. So people touch a piece of the solar system, and in this way it stays shiny. And it's the oldest thing that you can ever touch in your life. It's older than Earth itself. We estimate it at 4.7 billion years old. It might be a little bit younger, but it's older than 4 billion years anyway.
When did it fall on Earth?
Yeah, we estimate 5,000 years ago, and it fell in a swamp area that has now been dedicated as a natural reserve, so nothing can be taken out of this location anymore.
Would you like to acquire any more meteorites in future?
Yes, because this is an iron meteorite. There are many more types. We have rocky or stone meteorites, and we have anything in between, also with lovely minerals and crystals in it, so I would like to acquire some more, yes.
And Space Expo also has a piece of the moon.
Yes, we have. We are one of the few locations in the world where you can get very nearby a real moon rock that has been taken from the last moon mission. So you can see with your own eyes how the moon looks like.
Well, come to Space Expo, have a look for yourself. In the meantime, this is Sean Blair for ISA Web TV, signing off.
This looks like as good a place as any. Alright, so today I'm going to try to collect some meteorite dust. You see, this last week has been the Geminid meteor shower, and so thousands of tons of material have hit the Earth in this last little while, on top of the 20 tons per day that hit the Earth naturally at any other time of the year. And it stands to reason that that material the meteors hitting the atmosphere burn up, leave some sort of dust, which can settle back down to the ground. Now, I have some nice clean snow which would make a good collector for me. Now, it stands to reason that if I find metallic particles in this snow, there's a good chance it actually came from space. It's cold out here. Now, it is possible that some material has blown in from dirt, but really it hasn't been very windy. And I did take a sample by putting a tray on top of that tower over there, and I did manage to find some metallic particles coming from that, as well as a sample of snow that I took from a 7-story building over in town. And I've taken some smaller samples from around here, and I get about the same amount wherever I take the sample from. And today I want to try getting a larger sample so I can actually analyze it a little more. Yeah, look at it under a microscope and maybe even doing a chemical analysis to see if they're actually meteorite particles. Anyway, got me a tub, little scooper. I'm just going to scoop up a large quantity of snow off the surface. Try to keep it as clean as I can. And then I'm going to melt it down and extract the metallic particles with a very strong magnet. Okay, I collected the top inch or so of snow in this area. Probably at least 20 square feet or so. I got me a tub of snow here. Unfortunately, I can already see that the snow is going to be pretty well contaminated with grass, seeds and stuff, because the snow isn't quite deep enough to cover the grass completely, so as I'm scooping along it knocks grass seeds off into it. But there shouldn't be very much dirt, and it also should be pretty easy to separate metallic particles from the grass. So I'm going to go ahead and seal this up and go set her in my basement next to the fire, next to the furnace, so it can melt. I'll see how much metallic particles I get out of this. Let me just turn this off for a little while. That'll be quiet. So here we are, after about 3 days. Looks like I got 10 gallons, however much water I have here. And as I predicted, it's got grass in it, but there's also quite a bit of other stuff. So let's see how much of that is iron. I have this here N52 neodymium magnet inside of a plastic bag. It's nickel plated, so the plastic will help me from getting any contamination from the magnet itself. And I'm just going to run this around inside here. Ooh, water's still cold. Just run that around inside there, see if I can pick anything up. Ooh, that's cold. Let's see what we got. Alright, I can see some material right now. Not sure what you're picking up in the camera. Probably nothing. Not very good resolution here. Yeah, I can definitely see some material stuck to this magnet. Right around on the edges. It's not a whole lot, but I didn't expect a whole lot. Ah, there you can see it a little bit in the camera there. See that dark line? Right there. With my eyes I can tell that it's metallic particles. I'm gonna see if I can get this off there and put into a small vial so it'll be a little easier to see. Okay, I got the magnet out of the bag and I washed the material off into this bowl. I don't know if you can see it right there. I got the magnet underneath the bowl, by the way. But now, you can see that it's definitely moved around by the magnet. So I'm going to try to collect it all into one spot. Now I'm going to put it into this vial. I have a pipette here. Okay, that obviously didn't work because the magnet's still attracting it. But I can use this to kind of herd the material together. It's an interesting trick, just learned. Okay, take it off the magnet. There we are. Okay, vial. That could have probably went better. Well, I think I got some in there. May have spilled a little, but definitely got most of it. Hang on, let me set the camera down for a second. Oh, there it is. Okay. You can kind of see it in there. It's definitely clumping together because of the magnet. Oh, that's perfect actually. If I move it kind of close to the magnet, you can see it. Alright, let me set this up a little bit better so you can see it better. Not easy as it looks. Okay. There's the material. There we go. That's a good view. Let's zoom in. Alright, now I'm going to rise it up so that the magnet's just above it, and there it goes. There. Bring it down, up, there. So that shows that it's magnetic. Very nice.
Gone down that way.
Maybe 70%.
we're a lot further away from help here than we are just about anywhere else I've ever worked. Certainly, you know, we're several hundred miles from the nearest support, and there's no guarantee that that support could actually show up if we were to need it. So we have to be very self-sufficient for long periods of time.
I'm sitting here about 500 kilometers from the South Pole in the middle of Antarctica on a pile of rubble, a moraine that was pushed by that formerly huge glacier that you see in the background here. That's now almost gone, exposing everything that was transported in the ice, and that's exactly why down there we found about 300 meteorites.
If something out of this, all these samples turns out to be a Martian or a lunar sample, that's a very special thing to be involved with, is seeing that in the field. It's a little harder to identify Martian meteorites. They look very similar to some of the other asteroidal meteorites, but certainly many of the lunar meteorites are easily distinguishable, and to be able to see that on the ice and go, wow, that came from the moon, you know, and here I am, you know, being able to pick that up. When was the last time that we were on the moon to collect samples? The important thing about sending humans to the moon or Mars is the context from which the samples were obtained. And that's a very important scientific piece of information that is lacking with these rocks that we get here.
Let's set it on the ground floor.
One of the things that I think can be really incredible to hold is an iron meteorite, because they're solid nickel iron minerals. They're incredibly dense. They're about 3 times for size the weight of a normal rock you might pick up off the crust of the earth. And so just even feeling their mass, you know you're feeling something really different, but it's a natural rock that comes from, we think, the crystallizing core of sort of mini planets.
Are you ready to receive data?
Doing field work and having teams here in Antarctica will support future lunar exploration, and preparing not just the astronauts but the engineers who are going to be supporting the space missions, as well as the engineers who are doing things like designing the spacesuits. Future exploration using both humans and robotic spacecraft or robotic assists for humans is absolutely the way that we're going. And so we know that robots can explore planetary surfaces. What robots can't do really efficiently is recognize whether something is a meteorite or a terrestrial sample, and those are things that only human beings can do, and it has complete relevance to the way we might explore the lunar surface, for example.
So microtectites, you have a big asteroid that hits, and this one hit somewhere in Indochina or Southeast Asia. And it was so energetic that the impact was so oblique or so kind of angled to Earth that when it hit, it melted the Earth on impact, and then it traveled all the way to Antarctica. I mean, it's amazing how far this stuff travels. It's interesting all the different missions that are happening now to see how we can mitigate if there is an asteroid that is coming close, what we could do to kind of push it off the orbit a little bit, and how people are realizing it's a real threat and kind of trying to figure out how to mitigate that threat.
Noch interessanter finde ich persönlich erstmal, weil es sehr relevant ist für alle Menschen im Prinzip auf diesem Planeten, ist, dass wir ja irgendwann mal vielleicht in die Situation kommen, wo wir die Erde von einem Asteroiden schützen müssen, der Kurs auf unseren Planeten genommen hat, und dann uns vielleicht eine Mission überlegen müssen, wie wir diesen Asteroiden umleiten, um ihn von der Erde wegzuschleppen zum Beispiel. Und da ist es sehr wichtig zu wissen, aus was diese Asteroiden gebaut sind. Was für Material das ist, mit wem wir es zu tun haben. Die Dichte, die Oberflächenbeschaffenheit, die Bruchfestigkeit, wenn wir da vielleicht einen Anker in diesem Asteroiden befestigen, hält der dann und so weiter und so fort. Das ist sehr wichtig, und das können wir tatsächlich aus diesen Meteoriten ableiten, die wir hier in der Antarktis finden.
So what I would like to be able to do is get the terrestrial ages of the meteorites and then compare that to the age of the moraine, and the difference between those ages may give me some idea of what the transport time of the meteorite in the blue ice was between the time it fell and the time it ended up here on the moraine. So then the question is, well, how is it that in some areas we find hundreds of meteorites and in other areas we don't find so many? And so the answer is there has to be some concentration mechanisms. And the traditional idea has been that it's the movement of the ice sheets that concentrates these meteorites. The other thing is that, we've been out here and we've experienced a little bit of this, is that the winds are just horrendous. And so we know that for the smaller meteorites, the winds can push them along the ice sheets. And so we know that we find lots of meteorites in windrows and on these little moraines.
It's amazing to feel like I'm the first person ever to see this rock, maybe, or that piece of snow. It's really unique. I never thought I would do this, even a few years ago.
We're going to be making breakfast tacos.
All right, we have Christmas and New Year's dinner.
You want a cutting board? Okay. Now we have a food truck.
Okay.
Maybe just do one without. You can use the same thing. So Johnny, what do you want to tell us?
Presents!
Yay! Wow, more.
Oh,
that's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Happy New Year!
Okay, January 11th, 1912, Amundsen. At last the weather has improved. After having snowed all day, it stopped. We did not expect this. The weather has improved gradually, and it seems if we have good weather in prospect. We are lying in the cairn at 84.15, but we'll reach our depot tomorrow.
Little tiny tent feels like a home. The more time I've spent here, the bigger and bigger the tent feels, and it feels like, yeah, like we're all family, and we've all become so close in such a short amount of time that it just feels normal.
Hardest rock.
It looks like to me that it's gonna dump a lot of snow, or at least make it pretty unpleasant to come out here.